So I have a pendulum clamp and everything hooked up. If you look at the picture on the front of your activity here, I have a pendulum, right? It swings. It's a Yogi Bob on a string. Gravity pulls it down. And instead of a string across, I have a bar across. And then I have a cut short bar that we'll get to in a minute up here. So we see a little demonstration of the things that will happen. So steps 1 and 2 I put up here. We already did the discussion where we talked about kinetic energy can be turned into potential energy, or potential energy can be turned into kinetic energy. We're going to make a prediction. So we're all the way at step number 4. So if you turn over to step number 4, if we turn over to step number 4, it says, predict the height of the ball will reach if the ball is released at the same height as the horizontal string, which is this bar. So if I take this and I release it, our choices are A, the ball will go higher than the string, or the bar over here, go higher. B, the ball will go just as high. Or C, it will not go as high, it will be less. So you got a clicker. Any one of you should be able to say to yourself, if Mr. Noon releases this pendulum bob from this height right here at the bar, will it go A, higher than the bar on the other side, B, just as high, or C, not as high? You pick one of these up here. So I got A, B, or C. And then hit enter. So I have 72% said B. We got everyone? I got all students have answered. Oh, look at that. Did people change their answers when I showed that?
Yeah, because some were A.
All right. We're going to have to lock in those votes there, the lockers. All right, check it on your paper. Check it. Check the one that you picked. So I got B and C. I got B and C. 81% of you said B, and 18% guys had C. Anyone want to tell me? They want to explain why they picked B?
Equal and opposite action reaction.
All right, so you got Newton's third law that says every action is equal and opposite reaction. What is it that we're specifically talking about yesterday and today? Conservation of energy, right? So when I raise this ball up, what does it have?
Potential energy.
It has potential energy because of its
Height.
height. When I release it, at this point, let's say, if the string doesn't break, we'll say that's as high as it could be. So at this point, does it have any more height that it's allowed to travel? No? So we lost all the potential energy. What was it converted into? So in the speed. So we have the kinetic energy. The mass is the same, right?
Yeah.
So we have all the speed. Now when we have the speed, what's slowing it down now?
Gravity.
Gravity, air, friction. I heard that in there. So conservation of energy says that if we took all this potential energy, we had a certain amount of potential energy, and we converted all of it into kinetic energy, we should still be able to convert kinetic energy all the way into the height, which is the potential energy, right? Sure, maybe what if we went higher though? Could we go higher? No?
Not unless you threw it.
All right. Good throw. So, you mentioned something. Anyone want to discuss C? Did anyone pick C? They want to discuss why they might have picked C? Sam.
Air friction and stuff.
Air friction. What does friction do? Resist motion, right? Kinetic energy is the energy of motion, and friction resists motion. So, Sam, you believe that it will not go as high as this bar because it will lose all that energy by trying to push the air molecules out of the way. All right, you guys want to see it?
Yeah.
You had a question first. What? All right. I'll put it up here. I'll even put my nose up here. You think it'll hit me in the nose? Yeah, you hope?
It's gonna get pretty close.
It's pretty close, okay. Are you ready? Was it as high?
Yeah.
Who said no? Nobody said no? I thought I heard someone say no. Okay, so when is high? So Sam, I mean, there is air and there's air resistance. Why didn't the air resistance? Wasn't enough. Well, you do know something, right? Watch this, right? It's on my nose. Let me put my eye like that. Did it hit me in the eye?
No.
So it does lose a little bit, right?
Eventually,
So as it continues to go, what continues to happen? The friction. So as it's moving, and obviously at some point, all right, in one swing, we can get it up there. Second swing, a little bit less. Third swing, a little bit less. So as it continues to move, the air does take away that energy, right? It absorbs that energy. So we lose it, but not enough air friction to stop it the first time through. All right. You guys got the gist of what we're doing here? All right, let's look at the next thing. All right, so now we released it, we recorded our observations, so predict what would happen if a rod were attached higher than the string. All right, so I have a rod here, and we're saying this is a string here, so I'm going to attach this. I'm going to raise it. I'm going to raise the bar. All right, so there we go. So it's up above. Now it says, I'm gonna hide this for those people that change their answers when they see the poll. There we go. All right. So here we go. We got A, B, or C. It says predict what would happen if the rod were attached higher than the string. And then we have the same thing, A, B, or C. So I'm going to release it from the same height as the bar, just like last time. And it's going to swing through. When it gets over here, is it going to be higher than the bar? The same height as the bar? Or lower than the bar?
Where was it equal to?
B is equal. So A is above.
Where was it before? I'm saying the last question.
All
Where
right.
was the bar? The last question.
to that one.
All right, so I'm going to let it go equal to the bar.
Okay.
All right, so I'm gonna let this. No, that wasn't. Yeah, the bar wasn't on there before. This is new. Just put it there. So I'm gonna let this go, and I want you to predict A, B, or C. If when this green ball comes over here, it'll be above the string. That's A. The same height as the string. That's B. Or lower than the string. That's C.
And that bar above it wasn't there before in the last question?
Yeah, this I just added this.
Okay.
So obviously the string can't get through the bar there. So I got four people have decided. And remember, I'm not showing you what other people decide.
Can you lock our answers then, Sean?
I can lock them and then show you. I didn't think people would be so sneaky when I'm being observed as they change their answers and fill me out.
Just know it. Oh,
9, 10. Who was the last person?
Sorry.
Christian Baker. Christian Baker. A, B, or C. No, you gotta come to a decision yourself. You gotta come to a decision.
Oh, D?
Yeah.
yeah. So predict.
You got it?
No, whatever.
We still won't know what you picked.
Oh, you're gonna fail.
All right, so now write it down on your paper. Stop this question. All right, there's our results. All right, so A was above. 36% of the people say that it's gonna go above the bar. Above the bar. 45 say the same height as the bar, and 18% say below the bar. Is there anyone who picked A that would like to tell us what, yeah, okay, why?
Because the string is shortened at that point, the energy is focused on a shorter string, which would cause the ball to go higher.
It's gonna travel the same distance, it's gonna do the same amount of work.
So, or is, you're picking A?
Yeah, okay.
You picked A, same amount of work, force times distance. So
Yeah, the
what does that mean? Higher than the bar?
The height's changing.
Because,
Yeah.
because before you win a
Before, the
specific
distance
height?
was gonna, like, it's got a shorter radius, but it's still gonna go the same distance.
Alright. And then, you have the same thing because it should have this whole string worth of distance. And now it only has that much of the string, so it should go higher because it has more energy.
It's the same amount.
Okay, that's the same one. Okay. So, who picked C? Below the bar.
That was me.
And why do you think below the bar?
I wasn't sure, but I just pictured it hitting that, and it would slow it down.
Kind of like if someone's running down the hall, someone's
Yeah,
standing
you
in front of them.
clothesline them.
You clothesline them,
They
but
wouldn't
you
go.
flat on the
Yeah.
back. All right. Anyone have any different they want to share for why they picked C?
I had the same.
Same reason?
Yeah.
Okay, so it's taking away energy because it's physically getting in the way of the obstacle. And is it safe to say why people picked B? Why would you pick B? Anyone want to tell me why they picked B if they picked it? Anyone pick B and want to throw out there?
45% of people pick B.
I would pick B.
Come on.
You want to know why I'd pick B?
Is that the right answer?
It's the right answer.
Because this is why I would pick B. Now, I'm not saying if it is or isn't,
Oh, bodies.
but I would pick B because the potential energy was how high this little Yogi Bob was. That's how much energy this little mass of an object. The string doesn't have much mass. I use pretty string, I got thinner string. I can do it with thinner string and say the string has no mass, but I use my pretty pink string
Thank you.
for Christian's pleasure.
Yes.
Right? So the kinetic energy that was put in here was because of the height of what?
Ball.
The ball, when the ball was this high. And now it's the speed of the ball, right? So what is it if the kinetic energy, the speed, is going to be turned into what? And what of the potential energy if I don't change the mass? The height. So the height from here is where?
Same.
Same to the bar. I'm not saying that's right. I'm just saying, I'm trying to describe the conservation of potential energy to kinetic energy
So it's
back against the potential.
So, sounds right.
So you guys want to see it?
Yeah.
All right.
No,
All right, let's see. You got the tape rolling on this so that if
Yeah, I
anyone
got it.
complains, we can play it back later, just like they did the football game on Monday
right
night.
up to your nose.
All right, you got it? You ready?
Yep.
Put my nose there again.
Yeah, 'cause
Oh,
you'll
yeah.
come.
Hey!
Oh, what do you know?
B's the right answer.
All right, B was the right answer.
No.
Not that there is a right answer.
Who's gonna put B?
All right, so,
Change the law.
So you
Uh,
said it does that just because it maintains.
Well, let's just put in D everywhere else.
Then D's gonna be like one of these.
the mechanical energy of the entire system should be maintained, except for the fact that there's air resistance. But what we learned in the first one was that there wasn't enough air resistance between point A to point C to, huh?
Is there anything that affects mechanical energy?
Friction, air resistance, any applied force.
Oh, okay.
But right here, the only type of thing that could affect this ball is air, because it's on a string, it's not in the table, nobody's pushing it. All right, so you write your prediction, which I already have locked up here with your name specifically.
Yes, I get it, yeah.
And you put your observation, what did you see happen? Was it A, B, or C?
B.
It was B, okay, it was just the same as high as the bar. All right,
Did you answer the question?
what's that?
Did you answer the question?
Yes, I did. I learned from my mistakes. All right, so now we're on question number 7. What would happen if I attached the rod lower? All right, so here's the rod.
Probably gonna go with B.
Oh my god.
he would say something like that, and then he would secretly change his answer,
Yes, I would.
so that everybody else was thrown off by his big leading.
Yeah, that string can't reach all the way up to the
Right.
bar.
So, all right, there we go. 3 students have already decided before I even finish the bar.
Well, I wonder why.
We put the bar right there. See, how about now, Christian?
Oh, crap.
I know, we
All
got our
right.
answer.
All right, so you
That
can
was
put your
logic.
answers in as well. So I'm going to put it right here around the red tape area.
I'll go a little higher just to see.
No, not.
Yeah, what do you want to write?
All right, so.
You have to put up a little more.
No, it's.
You guys are trying to make your answer right. Put it up a little more.
Why wouldn't we?
All
I
right.
know.
All right, so here we
Make
go.
it
We're
wrong.
trying to- here we
Move it
go.
lower.
There we go. So here we are. I have 7 out of 11 once again. 7, 11. All right, so I let the ball go from the end of my nose like a clown. And the ball comes through here. Uh-oh, the bar's in the way. Does it go higher? Can it go higher?
I don't know, let's test it.
Yeah, it can go higher, right? So does it go higher than the bar? Does it go lower than the bar? Or does it go just as high as the bar? A would be higher, B would be just as high, and C would be below the bar.
There's one kid that has an answer.
And it's not Christian's.
No, it's not.
All right, everyone answered. Here we go. Boom. Everybody pick B.
I let it move on.
Everybody pick B. Really? Okay. So I raised it below the bar though. It's below the bar.
I know.
All right.
It's gonna be the worst.
So I'm going to assume that the majority of people picked B because they said, well, Mr. Noon just said that if you have a height before and it's converted to a velocity, you'll get a height afterwards. Is there anyone that came up that has something new and exciting to share with us why B would be the right answer?
Nope.
Is there anyone who wanted to pick A or C but felt, what did you want to pick?
I think I would.
You would go with C, but you just didn't want it. All right, and C was below because you're thinking to yourself,
Well, no, I did it before you put up the bar. I had it up
A.
because I figured you were gonna put it up higher.
It's gonna go higher than the
all
bar.
right, so let's find out.
Oh,
It's kind of low. I mean, I wanted to make it so that, yeah, sure, it could reach above the bar, but I wanted to make sure that it was just low enough so that maybe it could only go this high, right? You see something like that?
Oh, God, it's above the bar. No.
Just don't worry about it. You'll be okay. It'll be the right answer.
Oh, Christian, excuse me? I see you put it
Well,
in
see, I learned my lesson.
All right, Christian,
Okay.
Christian is trying to, all right, here we go. You ready, Ellie? Can you see okay? Let me put the computer top down. We got this on tape.
I'm just so nervous about my answer right now.
But it's going for a grade. This is
Yes,
something
okay.
great for the
Here we go.
winter.
All right, it's right here on my eye. No!
Just as
It
I-
looked like it actually looked like.
We're the same.
Came up right here. We got it on tape. You want to see it again?
Yeah.
Is there anyone who doesn't believe it went that high? No?
No, I saw it. That's what
Is it equal?
Oh, hey!
All right.
Oh.
There's still one picture.
Observations, write them down.